All right. Now think of a material that's 10 times stronger than steel, but only a fraction of that material's weight. It sounds made up, too good to be true, something that would be used for spaceships to fly into distant galaxies. But that material is real, and you've probably all heard of it. Its name is carbon fiber, and as a matter of fact, it is used for spaceships. Now, by the end of this speech, I hope that you guys understand the creation process of carbon fiber, all its different applications, and why it isn't as utilized as it is today. Now, carbon fiber has a multitude of purposes in the world. It's extremely strong, as I previously stated. It conducts heat and electricity spectacularly, so it can be used in big machinery and small electronics. But its main attraction is its weight. It's incredibly light, which means that it has most of the properties of metal, but none of the drawbacks of it being too heavy. And this is because most metals and alloys get their strength from density. Here you can see that across the board here, an item material gets more dense. And here the steels and the alloys are extremely dense and have respective strengths to that. But carbon fiber is super light and has a strength that surpasses everything here. Why? Well, carbon fiber gets its strength through chemistry. In an article published April 21st, 2019, by Todd Johnson on how carbon fiber is made, he explains that carbon fiber is a fiber, as a matter of fact. But it's quite an ugly looking one. It looks like that. And it's made chemically in a specific way so it can be treated numerous times to be hard and basically resilient to all matters of force. And so once they get this fiber, they put it into a furnace, and it's heated to 590 degrees. And here, it takes the oxygens that are in the furnace and infuses it into the fiber to completely change how it looks and is. Then they take it out, cool it, put it back into another furnace. This one's special, as it heats it to 5,500 degrees Fahrenheit. And here, it sheds all the other chemicals that are present, except for the carbon. And the carbon left crystallizes and forms together to create an almost unbreakable bond. And it smoothens out to get this type of look. Now, engineers, once they finally were able to get this, realized that they could do three things to make it even stronger. One, by letting it cool, the oxygens in the atmosphere just infused in the gaps that were present in the carbon, making it stronger as a whole. Second, they thought it was a fantastic idea to start stripping it individually and weaving it together like a hand basket. That creates a pattern that looks like this, how carbon fiber usually looks. So usually it's hand woven, but they've done now machines that can almost replicate something like that. And the little white shimmers that you see are resin. That's the third thing. It's like a sticky substance that works as glue, that isn't heavy at all, but strong enough to keep everything together. So now that they have this super strong material, what do they do with it? Well, in its lesser known fields of construction and in the medical field, they use it for prosthetics and support. In the prosthetic field, they use it for amputees that have amputees that have lost limbs, as the material can easily bend to different forces without breaking or shattering. But in April 8th, 2014, Tae-Im Yi published in the Journal of Foot and Ankle Research that he could create carbon fiber soles that worked better than foam soles for people who had arthritis and lower back pain. Now, they look super uncomfortable, but studies have shown that they're way better than foam and other gelatin supports, which is absolutely remarkable for being a composite material. In construction, Katsuma H. published in his report of technical research in 1989 that he could replace rebar in concrete to make structures with carbon fiber that were almost impervious to earthquakes. And that's how they usually filled in instead of rebar. So why isn't it as used if it's some kind of miracle material that can be used for almost anything? Well, it's primarily used in aerospace and in the automotive industry, but not widely used. Why? Well, in the article published in the Journal of Aircraft, April 2010, by L.A. Burns, it's not used more in aerospace because the jet engine that planes usually use and the rocket propulsion that rockets use usually melt the resin that's present in carbon fiber. This makes it incredibly weak, and due to the sudden change in strength, can cause the carbon fiber to be brittle. And William Diem put in his 2004 publication of Auto World that it's too exotic. The process that I explained takes an immeasurably long amount of time. It requires enhanced specialists to do it carefully and precisely, and it's expensive on top of that. But for students like me in material engineering, this is the future. To be able to make materials that are incredibly light but strong enough to withstand almost any force, we can make structures and technology and machines that can do essentially anything we want, but that can be light as a feather. So while we may be limited today by the skills of our technicians and the limitation of our technology as a whole, great strides are being made so that carbon fiber can be the material of our future. Thank you.